Hi, I'm Kavita. Let us see 2025 previous year board exam question papers MCQs. A question is, assertion is let A equal to X belong to R minus 1 less than or equal to X is less than or equal to 1 if f is from A to A be defined as f of x equal to x square, then f is not an onto function. And the reason is if y equal to minus 1 belong to A, then x equal to plus or minus root of minus 1 not belong to A. This is simply MCQs, so don't go to theory part and all. Let us solve this simply. Here, f is what is A to A. Let us take a function is from A to A. And its elements are given as real numbers from minus 1 to 1. So let us simply take minus 1, 0, 1, minus 1, 0, 1. Here this is x, this is codomain. Now here y is what is x square. F of x is x square. F of minus 1, 1. F of 0, 0. And f of 1 is 1. So minus 1 is mapped to 1, 0 to 0 and 1 to 1. It is not 1 to 1, but no need to go there. Here f is not an onto function, that you have to check it. Here minus 1 is there. It doesn't have a pre-image. So f is not an onto function. Onto means what is? For each element in codomain, there should be a pre-image. So here f is not an onto function. So your assertion is true. Now come to reason. Here, if y equal to minus 1 belong to A, then x equal to plus or minus root of minus 1 not belong to A. Here what is? Y is x square. So, x is what? Plus or minus root y. Y is, if you take y is minus 1, x is plus or minus I. That is imaginary. But x is what is? A real number from minus 1 to 1. So, your reason is also true. That is, y equal to minus 1 belong to A and x equal to plus or minus root of minus 1 not belong to A. This is a correct explanation of this assertion. So, here option A is right. Do you understand? Thank you. Question number 2. Assertion is let f of x equal to e power x and g of x equal to log x, then f plus g of x equal to e power x plus log x, where domain of f plus g is R. F is e power x. That means its domain is minus infinity to infinity. G is what is? Log x. So, its domain is 0 to infinity. For f plus g, we have to take the common domain of f and g. For f, what it is? Minus infinity to infinity. And for g, that is 0 to infinity. So, for f plus g, the common domain is 0 to infinity. F plus g, the domain is 0 to infinity. But what it is given, domain of f plus g is R. So, assertion is false. Next, reason. Reason is domain of f plus g equal to domain of f intersection domain of g. This is the fundamental rule of domain of sum of functions. So, reason is true. Assertion false, reason true. Do you understand? Thank you. Question number 3. If f is n to w is defined as f of n equal to n by 2 if n is even, 0 if n is odd, then f is injective only, surjective only, bijective, neither surjective nor injective. You have to check these 4 options. The function is given. Here, what is given? F is from natural numbers to whole numbers. Natural numbers 1, 2, 3, 4, 5, 6 up to infinity. Whole numbers is 0, 1, 2, 3 up to infinity. Here, if n is odd, f of n is 0. So this 1 goes to 0, 3 goes to 0, 5 goes to 0. All odd numbers go to 0. And here if n is even, f of n is n by 2. So for 2, 2 by 2 is 1. 4 by 2 is 2. 6 by 2 is 3. Here all odd numbers go to 0. That is many to 1. This map is not 1 to 1. Not 1 to 1. That means it is not injective. And see here, every element in the codomain is mapped by at least one element from the domain here. Here, all the elements in the codomain have pre-images. So, the map is surjective, that is onto. So, option 2 is right. And that is not 1 to 1 but onto. Bijective means it should be 1 to 1 and also onto. So, option 3 is wrong and option 4 is also wrong. So, the answer is B. That is what is surjective only. This is your answer. Thank you. Question number 4. For real x, let f of x equal to x cube plus 5x plus 1. Then f is 1 to 1 but not onto an r. F is onto an r but not 1 to 1. F is 1 to 1 and onto an r. F is neither 1 to 1 nor onto an r. Now here, what is your f of x? That is x cube plus 5x plus 1. The function is real. So, real number to real number. Yeah, every element in the domain has a unique image. So, the function is 1 to 1. And every element in the codomain has a pre-image in domain. So, it is onto. So, option C is right. F is 1 to 1 and onto an R. Thank you. Question number 5. Assertion is, let Z be the set of integers. A function f is from Z to Z be defined as f of x equal to 3x minus 5 for every x belongs to Z is bijective. The function is what is? F is 3x minus 5 and Z to Z, integers to integers. F of minus 2 is what you are getting? Minus 11. And f of 1 is minus 8. F of 0 is minus 5. F of 1 is minus 2. So, minus 2 to minus 11, minus 1 to minus 8, 0 to minus 5, 1 to minus 2. You can map like this. That means what is? For every element, for each element in the domain has a unique image. That means what is? It is 1 to 1. And Here the function is not onto. Why it is not onto? Here minus 10 is there, no pre-images here. For minus 9 also no pre-images here. So the function is not onto. That means what is? It is not bijective. But in your problem, it is given that the function is bijective. So our assumption is, assertion is false. Reason is what is? A function is bijective if it is both surjective and injective. Surjective is onto and injective is one-to-one. The statement is right, so the reason is true. The answer for this problem is assertion is false and the reason is true. Thank you.